Do you have a situation where your hot or cold water pipes freeze when it gets really cold outside? Have you had one burst? Are you worried about it? I had that situation, and I developed an automated system to keep them from freezing. It's simple. Anyone can build it. I'm going to show you how to do it in this video. My name is Craig Foreman, and I developed a simple solution to freezing water pipes that I will share with you. My situation is that I live in the Northeast USA, where I own an older home used as a rental property. It has copper hot and cold water pipes running near the exterior of the house from the basement up to the second floor apartment. It seems that once or twice each winter during a cold snap, I get a call from the tenants that the water to the second floor kitchen is not working. I quickly hurry over to the property, only a couple of miles away, and use a hairdryer in the basement to heat up those water pipes that run up to the second floor kitchen. Usually after a few minutes of heat, the water will start running and it will clear. I've never had one of the copper pipes burst, but I don't want this to happen. One year, the freeze up did cause the plastic feeder valve under the dishwasher to crack, and when it thawed, we had water flowing all over the kitchen floor. I've asked the tenants to run a little warm water from the faucet on really cold nights, but that's unreliable because they could forget or they could be out of town, plus it wastes a lot of water. So I thought about ways to automatically turn on a hairdryer for a few minutes on really cold nights to prevent freezing in these copper pipes. I wanted the system to be automatic, reliable, and flexible to adjust. I used my engineering background to develop a system using a couple of electronic devices that's simple and reliable. It can be built easily by anyone with simple mechanical and electrical skills. It's flexible enough that it can be set up to run multiple hair dryers if you have a freeze-up problem in several different areas. Plus, all the components are readily available and quite inexpensive. Outside of electrical cable, if you have to add outlets, the component cost is less than $50. Now let's talk about the three basic electronic components that you'll need to buy. First, the Tech KT3100 digital temperature controller with outlet socket. This is the brains that's going to measure the temperature and start the system when the temperature falls below your preset trip level. This is available for less than $25 on Amazon. Second, the Defiant 31072 digital countdown timer with outlet socket. This is the device that will run your hairdryer heater for 5 minutes or whatever your desired time interval is once it's started. These are available for about $8 at Home Depot. Finally, the multi-channel 5-volt DC relay board for Arduino or Raspberry Pi. These are available at computer parts stores or on eBay or Amazon for less than $8. Now let's take a closer look at the three basic electronic components. First, the Tech KT3100 digital temperature controller. This device comes with a temperature sensor with several feet of lead length. You're going to want to place that sensor in the cavity where those water pipes enter the wall area. It's going to sense when that area starts to get really cold. The device can be programmed to turn the outlet either on or off when the temperature falls above or below a trip level. We're going to use it in a mode where the outlet will be turned on when the temperature drops below your preset trip level. The outlet will then be turned off when the temperature rises above a second preset trip level. Now the Tech 3100 has three display lines. The top line displays the actual temperature being measured by the temperature probe. The second line is the temperature at which the outlet is turned on, and the third line is the temperature at which the outlet will be turned off. We will always have the second line, the start temperature, at a lower set point than the stop temperature. So when the cold temperature is reached, the outlet will turn on. Once the heaters kick on, the temperature will increase rapidly and will shut off when it reaches the stop temperature. One other thing to note is that the Ketotech displays temperature in degrees Celsius, not degrees Fahrenheit, and there's no way to change that. So this is the Defiant digital countdown timer from Home Depot. It has many other functions, but we're only going to use the countdown timer function to time how long the heaters will remain on. Normally you press the countdown button to start the countdown. However, we're going to actually remove the countdown button and substitute a relay contact for pressing the button. Now this is the 5-volt DC multi-channel relay board. These are made in single channel, 2-channel, 4-channel, and 8-channel varieties. The number of channels that you need depends on how many separate hair dryers you want to control. For each hair dryer you want to control, you need a separate channel. So if you're only using 2 hair dryers, you only need a 2-channel board. So here's how we're going to use the relay board. We'll use a very small 5-volt DC power supply that will plug into the output of the Ketotech temperature controller. When the outlet is energized, that DC voltage will turn on all the relays on the relay board. That will provide a short contact closure that we'll use to trigger the countdown timers. Now here's some other electrical items that you'll probably need to buy. A 2-gang wide and an extra deep plastic work box. This is your main work box. It's going to have outlets for both the temperature controller and the countdown timer. And it's going to have enough room that you can put the relay board in it as well. Therefore, you need a box that's 2-gang wide and extra deep. You'll need duplex outlets, and if you want to, you can get switched single outlets with indicator lights. These are kind of nice because it would just give you a way to flip a switch and turn the whole unit off when it's not the season where you're worried about pipe freeze-ups. Finally, you'll need to get solid hookup wire. Hair dryers use a lot of current, and depending on how much you're running, you'll probably need 12-gauge wire. Now another thing you're going to need is a 5 to 6 volt DC power module. These are easy to find. They're used very commonly for all sorts of small devices like cell phones, USB devices. Find one, you might have one sitting around in your drawer, that is marked either 5 volts or 6 volts, and the output current doesn't really matter because you're going to be drawing very little current. If you can't find one, you can easily buy one at a drugstore or an electronic supply store. You may have one that has a molded cable as shown in the top, or you might have one that has a plug-in cable as shown in the bottom. So it really doesn't matter which kind of 5 volt, 6 volt DC power supply you have, whether it's molded or it's a USB cord. You're going to need to strip the end off and isolate the plus and minus wires. The plus wire is usually red, and the minus wire, also called ground, is usually black. You'll need to isolate those wires and strip and tin them because we'll be connecting them to the pigtail in another step. If you can't identify the wires, use a DC meter, a little multimeter, to check the different conductors and find the one that's plus and the one that's minus. Now we have to talk about wiring the DC supply to the relay board. You'll have a plus and minus 5 to 6 volt output coming from your power supply. Connect the plus wire to the VCC pin, which is shown by the red arrow. For the other wire, which is the negative wire, you'll want to connect it to the pin marked ground. You also need to connect it with a jumper wire to one or more channel contacts, depending on how many channels you're going to use. If you're going to use one channel, you run a jumper from the ground to the IN1 pin. If you're connecting a second channel, you add another jumper to the IN2 pin, and so on. You'll need a channel for each heater hair dryer that you're going to use, because each relay contact will control one countdown timer and one heater hair dryer. You can solder directly to the pins if you want, or you can look for a small jack that fits the pins to allow you to easily connect and disconnect to these pins. Now I'm going to talk about wiring the low voltage trip wires to the relay output contacts. These contacts will give you a closure which will activate each of the countdown timers. You'll need one channel for each countdown timer and each hairdryer heater in your system. You simply strip a little length off the end of the wire and you insert it in a hole that's behind each screw, and then tighten it down with the screw. Now for this, you don't need any heavy wire. You don't need 12 gauge cable or anything. You just need like hookup wire. It can be stranded wire. You need 2 conductors, and you can use like doorbell wire or really anything you have around. And you'll need to this is the wire that will connect to each of the pigtail outlets that you've soldered onto your individual countdown timers. Now at this point, your relay board should be completely wired. You have low voltage cables coming from each of the relay channels that you're going to use to trigger the countdown timers. You also have an input coming from the DC voltage module to power the relay board. You're going to want to position the board deep back towards the rear of the plastic 2-gang wide outlet box. You're going to want to do that because you're going to need to put your duplex outlets in front of that with your electrical wiring. You want to fasten the relay board to the back or the side of the outlet box with at least 1 screw. You can run the cables from the relay board through holes that you drill in the plastic box, or if there's existing holes there, you can run those wires through the existing holes. Now I'm going to talk about wiring the electricity to the 2-gang wide plastic electrical box using 2 duplex outlets. Caution: if you're not comfortable working with electrical wiring, you may not want to do this project. Otherwise, it's fairly simple to connect the white and black wires and the ground wire to the duplex outlets. The ground wires are probably either green or they're just bare wire, and you connect those to the green screws on the outlets. The white wire is considered the neutral wire, and the black wire is considered the hot wire. Make sure they go on the proper sides of the outlet as shown in the diagram. If you're going to use switched outlets, you want the switch to be on the hot side. That is the black wire. And finally, you want to mount the 2 duplex outlets onto the outlet box using the screws in each duplex outlet, and pushing the wires into the outlet box, making sure that the wires are not touching the ground wire or pushing against the relay board in any way. You can then use a too wide plastic cover to cover the outlets, and you can use 2 screws to tighten the cover plate down. So this is the most technically challenging part of the project, using the digital countdown timer, because you have to actually modify the device. We have to open it up and modify it slightly. So we've got the Defiant digital countdown timer, which comes from Home Depot. You won't probably find these in the store, but you can order them in and have them shipped to the store. They're under $10. They also sell the exact same countdown timer with a different name on it. It goes by the name of My Touch Smart Simple Set Indoor Plug-in Digital Timer, and Home Depot also carries that one, but it's quite a bit more money, and you can also find that one on the internet on Amazon. But the cheapest way to go is if you can get this Defiant countdown timer from Home Depot. So we're going to open it up and plug it in here. You're going to need a sharp knife for this part of the project, because we're going to have to cut some parts inside. So this is the digital timer, and when you get it, it has a battery inside. It may or may not be charged. The first thing you're going to do is you're going to plug it in. So the first thing you're going to do with the timer when you plug it in is you're going to have to set the time. These have a battery built in, so they retain the time, which is nice. So there's a little tiny button down here, and you just have to press that with something like a tip of something and hold it in, and it'll go into the set mode. And at that point, you're going to use the up-down keys to set the time, which is now 9:04 p.m. So I'm just going to go up, and we'll just set that until it goes up to 9:04 p.m. Okay, we're almost there. So we're going to set 9:05. Okay. So now it's set. Now, since it has a battery built in, if the power goes off, for a short amount of time or something, when you plug it back in, it should remember the time. I plug it back in, and there it is, 9:06 p.m., the same time as I set it. Now we're going to use this in the countdown timer mode. There's a little button right here that says countdown, and when you press that, it turns that little blue light on and starts flashing the time. We're going to set this for, initially you can set it up or down. I'll set it for 2 minutes. And so it comes on at 1 hour. I'm setting it down to where it says 0:02, which is 2 minutes. So now the countdown timer is set. You see that little blue light on. It's counting down, and it's going to operate the outlet for that amount of time. We'll pause the video here until it's almost done. So I'm plugging a test light into the outlet, which is on the side, so you can see when it turns off. So you can see that the little blue light's on, meaning the outlet's activated, and it's counting down from 2 minutes, and when it gets down to 0, it'll shut the outlet off. And that's what we're going to use to control the hair dryers that we'll use in our pipe defrost system. We want to set the hair dryers to go on for a limited amount of time, and I typically use 5 minutes. So every time it triggers, it'll turn the heaters, the hair dryer heaters, on for 5 minutes, and then they'll shut off. You aren't going to want these running continuously for a couple of reasons. Number one, hair dryers will take quite a bit of electricity to run. They usually run anywhere from 1200 to 1800 watts, and you don't want to have the heat just pouring out there for a long time, and you don't want to start a fire or anything. You want to make sure that there we go. So just count it down, and when it gets to 0, it just shuts off. Now if you wanted to start the countdown again, you would hit the countdown button, and would remember your 2 minutes, it's flashing 2 minutes now, it will remember the setting from the time before. So this is what we're going to use in our system. We'll set it for 5 minutes, and we're going to, when we trigger it, and we're going to trigger it electrically rather than pressing the button, it's going to turn on whatever's plugged in there, and that'll be your hairdryer. It'll turn that hairdryer on for 5 minutes. At the end of that time, it'll shut off. Now, in order to get inside this, which we're going to have to do it to modify it, we're going to need to take it apart. And unfortunately, there's 3 screws to take it apart. But unfortunately, they've used a tamper-proof screw. It's a weird screw with like triangular head, which there is no screwdriver in my toolkit to unscrew it. So the only way to get into this is to drill out the heads. So you want to take put it on a soft cloth, and you want to take about a 1/8 inch drill bit and just start to drill straight down into the hole so you can drill through the head. And you want to drill it not quite all the way through, so just drill it some and then try to see if you can get a screwdriver to fit in it. So let's give that a shot, see if we can do anything. I don't think I've given it quite enough, so I'll try drilling it a little more. So with this one, I did manage to get the drill in there and drilled into the head, but not all the way through, and I was able to get it to the point where I could get a screwdriver in there to bring the screw, what's left of it, out with a screwdriver. There it is. So there's the screw, and you can see, I don't know if you'll be able to see this. Let's see if you can see if this will show you what the screw looks like. There's a screw. You can see it's kind of a triangular head. It's hard to see there. But I've drilled into it, and I just left enough of that thread on there that I could get a screwdriver in there and get it out. That's what you want. You want to do that to all 3 screws. So if you can't get it out with the screwdriver, you're going to have to go to a little larger drill bit, one that's, you know, just about the diameter of the head, and you're going to have to drill the whole head out so that you can get that screw out. You don't want to do too much here. You don't want to go all the way through the circuit board. You just want to go until it breaks through. So at this point I was able to get 2 of the screws out with a screwdriver. The other one I couldn't get out with a screwdriver, so I had to drill through it. So now you carefully separate the unit, and there's a little cable in there, so don't break that. And what you're going to need to do is find the screw that you didn't pull out, which is this one. And you're going to need to get a pliers of some sort in there, and you're going to need to get that what's remaining of the screw head out of there. And you'll just do that carefully by using a small plier to try to grab whatever's left of it and turn it out. So now I've managed to I cut a little bit of the plastic away, and now I can actually get a plier, a small plier, on the head of the screw and start turning it out. And it will come out. And that way, when you're all done, you want to put it back together, we'll be able to just use some new screws, and we'll be able to screw it into the existing holes. We aren't going to use these screws. We'll discard them because they don't have a head that we have a screwdriver that can actually match them. So that's it. We've got our 3 screws out, and that is the inside of the unit. That little green device is the little battery, and there's not much to it really. There's a circuit board here, and we'll get into that in the next in the next step. So now that we've got the unit opened up, we're going to need to remove the circuit board. That's a circuit board that contains the button assembly. And in order to do that, there's 3 screws we have to take out. Now, 2 of the screws are visible at the bottom of the circuit board. I'm going to pull those 2 out. Save these screws because we'll use them when we put it back. Okay, that's the first 2 screws. The third one is under this piece of tape. And the piece of tape is just really an insulator. So just kind of just peel it back a little bit, and you'll be able to see the 3rd screw under there. I wouldn't necessarily take the tape entirely off unless you need to. We'll peel it back. And there's the 3rd screw. Now we're going to take that 3rd screw out. And we're going to save these screws. We'll put them back later. Got the 3 screws. Now we'll be able to work on the circuit board. At this point, that circuit board is just held in by some little tabs. And you can just gently pry it up from the end with a tool or something. And it'll come up. Make sure you don't break any of the wires. And so it's free now and it's out. And you want to just leave the rest of the unit over there. We're going to be working on the circuit board. And what we're going to do is we're going to take that button that said countdown, and we're going to replace that with a couple of wires that are going to be remotely activated by a relay. So for this step, we're going to want to take the circuit board, and we're going to want to find the button that's right in this position. It's right next to that little reset button. Remember the reset button? That was right. Remember that reset button that was right down there? It's right above that. So it's on the bottom right. And what we're going to do, it's got a little plastic film on top of it. We're going to take our knife and we're going to cut that film away so that we can get to the pads to solder some wires to. So I'm going to carefully make a couple of cuts in that. We're just cutting through the outer layer of film. And after you get it cut, you're going to hopefully be able to peel that film right off of there. And the button will come right out. I'm not going to use that button. So now the button is gone. The button's out of there. Now we have access to the pads that are underneath the button. And that's where we're going to solder our wires to for our remote start to start the countdown timer. So for this next part, you're going to want to find some very thin wire. You need 2 conductors, and we're going to drill a little hole to run that wire into the case opposite where the outlet is. So we'll drill a little hole right here on the other side. And we're going to run our wire wire through that hole. So now we've run the wire through the hole, and we're just going to take some cutters, and we're going to separate the two conductors, and we're going to strip them. And then we're going to get a soldering iron, and we're just going to tin those leads there that we just stripped. So they'll be easy to solder. A little solder on those. Okay. Now, this is what we're going to solder to. You see, there's an inside part of the switch, which is that little circle in the middle. One wire is going to go there. The other wire is going to go to the part that's on the outside. And we're just going to take our wire, and we're going to solder one wire to that little part on the inside. And you may have to just take a little bit off if it's too long. We're going to solder those into there, and that'll be for our remote control. So now we've got our two wires soldered onto where the switch contacts are. One soldered to the little dot in the center, and the other is soldered to that copper area around on the outside. At this point, we will cover it with a little piece of electrical tape to prevent shorting. So we want to dress that wire so it goes around all the switches and it doesn't cover any of the remaining switches. And when we put our piece of tape on, we want to make sure it's just a small piece of tape that doesn't cover any of the switches, and it also doesn't cover that little hole, because that little hole right there is going to be for mounting. At this point, we're going to put the unit back in its case. So now we need to put the circuit board back into the housing. So we're going to take the part with the switches on it. We're going to lay it down, and we're going to put the circuit board down onto that. There's four little oval shaped holes that will line up, and once you have those lined up, it should fall right into place. And once it's in place, we need to put those three screws in. We're going to have our wire dressed in such a way that it can get out that little hole on the side. So now we've got our three screws in place, and remember, one of them was under that piece of tape, so we've got to pull that piece of tape up. So we're going to tighten these screws down. That's going to hold the circuit board down. So when we've got all three screws tightened, we're going to just push that piece of tape back in place. So now that we've got everything screwed down, we just want to make sure that piece of tape is in place. We're just going to fold it over and close it, and it should just kind of go together pretty tightly, and make sure that our wire is hanging out that hole. And now we just have to close it up by putting the three screws in, and we'll have to use new screws. But before we do that, we're going to test it out, and we're going to do that by stripping the wires and shorting them together. So now I've stripped and tinned the two conductors from our pigtail wire. I've plugged a test lamp in the outlet, and we're going to plug it in and try it now. So I plug it in, and the time should be correct because we already set it. And if I short these two leads together, you see the little blue light goes on where it says countdown, and it comes up 2 minutes, which is what I had set before, and it's now going to keep that light on for 2 minutes and shut it off. So the outlet timer is now ready to wire to our external relay, which will cause a closure of the pigtail wire. So now we just have to put screws back in. I found some short screws that I'm going to use for the two where we didn't break through. I'm going to put those in just to tighten the case down. And for the other one where we broke through, I'm using a longer screw that can go all the way down from the case, and it's not going to be able to get through there, but it'll hold everything in place nicely. Now this is a photo of the two electronic units, the temperature controller on the left and the countdown timer on the right, plugged in side by side into the two duplex outlets in the 2-wide box. Now you can see that there's not enough width for them to sit next to each other side by side. So to fix that, I have added a grounding adapter behind the temperature controller so that it actually sets out in front of the countdown timer, but it doesn't harm anything because you don't need to get to any of those controls, and it just barely hangs over. Also, you can see that in the foreground the 5-volt DC power module is plugged into the output of the temperature controller, and the cable from that runs back into the back of the outlet box where it connects to the supply portion of the relay board. Now remember the low voltage 2 conductor wires that will be connected to each channel of our relay board to trigger the countdown timers to start? Those wires need to get connected to the pigtails on each of the countdown timers in our system. There's no polarity involved here. You just connect each of the conductors from the relay board to each of the conductors of each countdown timer and cover them with either some heat shrink tubing or some electrical tape, and everything will be connected. Now I'll show you the main area that I was trying to protect from a freeze up. It's right above this, up toward the ceiling here. I'm in the basement now. And if you look up there, you can see there is the hairdryer. It's mounted upside down, and it's pointing over to the corner. And that corner over there is where I've had the freeze up problem. And I've got the hairdryer pointing over there so that it will provide heat over to that area when the system turns on for 5 minutes. And that copper pipe will carry the heat right up through to the second floor where I was somewhere inside the wall I was getting a freeze up problem. So this is the temperature controller. I've got the outside temperature right now is registering 20.2 degrees C. I've got it set to go on at 0.5 degrees C, off at 10 degrees C. This is the relay, the AC-DC transformer that runs the relay board to turn the relays on and off. The relays are built back into this plastic outlet box. I've got it sitting in the back of that box. When the relay goes on, it's going to turn on one of the hairdryer heaters, which is going to trip this countdown timer, which is set to count down for 2 minutes. Sorry, for 5 minutes. And we'll keep the hairdryer on for 5 minutes. There's also a second relay output which I've run to another area where I want to heat the pipes up. You can see I've used a switchable outlet back here so I can just switch the whole thing off. when it's off season. And I'll show you this working in a second. This is my auxiliary countdown timer for a second hair dryer. It's also set to go for 5 minutes. It has a tripwire that comes from the main relay box. On the side of that, I've got the hair dryer plugged in. That hair dryer is facing right up to a couple of water pipes, which I have running along the side of the house that have a tendency to freeze up. Now I'm going to demonstrate the operation by forcing it on. I'm going to go press the set button and run the kickoff temperature up above the current temperature, which will kick everything on. Okay, there it just came on. And now I'm going to set it back down. So now you see the countdown timer is ready to take 5 minutes, and the blue light is on. That's the main hair dryer, that's running. I'm going to go over to the auxiliary hair dryer. It's this unit up here. You can see that one's also running. The blue light's on. That hair dryer is located right there. That's running to heat up those water pipes. And that's going to run for 5 minutes and shut off. Now you can see that there's about 1 minute left on the countdown timer, and you'll hear it shut off when it gets to 0. Could be somewhere less than a minute. And there it goes, it all shut off. So the whole idea here is that when it trips, it'll run the heaters for 5 minutes and then they'll shut off. And hopefully you won't have them coming right back on, because the temperature up there is going to stay, it'll start to fall. It's starting to fall already. You see it was up to 70 some degrees C. It's now at 68 and falling. And it's not real cold outside today, but it's set to trip and turn on at 0.5 degrees C, which is just over freezing, and turn off at 10 degrees C. And it reaches that 10 degrees C real quick after it turns on, because the temperature rises so fast once the hair dryer is on. So I've shown you just about everything that I did to build this system. I hope it has helped you in some way. If you do try it on your own, just be careful. If you're not used to working with electricity, maybe it's not for you. Just be careful about how you wire everything and run everything. Try it before you set it and forget it. And it's pretty adjustable. You can change the number of heating units you want depending on your needs. You can adjust the trip temperatures as to when the system kicks on. You can adjust the on time of the hair dryers. Just don't make them too long. You don't want those things running for hours or anything. You don't want to start a fire. So be careful, and I hope it helps you. And I got one other suggestion. To test your system on a cold night or a cold day, there's a way you can do it easily. You simply plug a triple outlet cube like this into your outlet on one of your controlled countdown timers along with the hair dryer, so that when the hair dryer is running, the outlet will be live. Then you're going to get an old style mechanical alarm clock like the one I've shown here. Set it to like 12 p.m. or 12 o'clock and just plug it into that triple outlet cube. And when you wake up in the morning, if it temperature dropped low at night and the time is reading 12:05 and you had your countdown timer set to 5 minutes, that means it came on once during the night. If it reads 12:20, that means it came on 4 times during the night. Now you don't know exactly what time it came on. You don't know how long it was, between the off time and the next on time. You'd have to have a more extensive monitoring system to see all that, but at least it gives you an idea of how much it's coming on during the night and whether it did come on or it didn't come on. It's a real easy way to tell. So that's about all on this project. I hope you got something out of it. And if you have any comments, you can leave them. And if you want to email me with any questions, I'm more than happy to answer them. I'll leave my email here. You see it right there. Craig@tradercoaching.net. And good luck on your project. Bye.